Let's solve this challenging problem. This may be one of the questions from a math contest before. So the question is, let p be a polynomial function with p at a equals to p prime at a equals to 0 for some real value of a. Which of the following must be true? So you are giving 5 options, 5 choices to select. So if you just look at the question itself, let's say you cover up all the choices. You don't have these choices. You don't have enough information to figure out anything. So what you have to do for this question is, you need to consider every single one of this option individually and independently. So let's begin. What does it mean by divisible? Because every single choice here says p at x is divisible by a function. So let's talk about what divisible means. So let's say you have a number 6. Is it divisible by 2? The answer is yes, you get 3. And you don't have any decimal. So basically it's not like you have 5 divided by 2, which you have 2.5. That's not divisible. So another example. Is a divisible by 4? Yes, the answer is 2. So you don't have any decimal like behind that. So what that means is that in order for a number to be divisible by another number, it's supposed to be a whole number. It's an integer. So let's go back and look at the question. Okay. So every single choice is saying that, oh, p at x is divisible by a function. So we can see p at x as a function. So what should we do? So let's say p at x, in order for a function to be divisible by another function, and it's really likely that p at x is consisting a product of 2 functions. So I would call the first function f at x times the second function g at x. If I let g at x equal to the function in each of these choices, would p at x be divisible by g at x? And we can see that this way. That's the same as f at x times g at x, because we say we said that p at x is f at x times g at x divided by g at x. And what that means, g at x cancel out, I have f at x. Then p at x is divisible by g at x. And the answer is f at x. So that's the thought process. So for question A, for choice A, I will let me do A first. Let g at x equals to x plus a is a function g at x. So p at x is equal to f at x times g at x. That's the same as f at x times x plus a. That's g at x, x plus a for choice A. So what are we looking for? So we have to keep in mind that this statement is valid. P at a equals to p prime at a equals to 0. So we have to see that if we plug a into x here, p at a, we are supposed to get 0. G at a, that's f at a times, now x is a plus a. Then this is equal to f at a times 2a, which is 2a times f at a. We don't know that whether that's equal to 0 unless a is equal to 0. But in the question, The question did not mention that A is equal to 0. So we cannot assume that that's equal to 0. Okay, we already look at P at A. Now we have to see P prime at A. Remember, we're looking for both here, P at A and P prime at A equal to 0. So what would be P prime at A? So this is the product of two functions. The derivative of the P at X will be the F prime at X. So maybe I can write it like this. Maybe it's easier for you to follow. P prime at X is equal to F prime at X times G at X plus F at X times G prime at X. So P prime at X is equal to, okay, we don't know what F at X is, so F prime at X will stay as F prime at X. So we have F prime at X times G at X. We said G at X is equal to X plus A, so X plus A plus, we don't know what F at X is, so leave F at X, but we know G at X. G at X is X plus A. Then G prime at X is the derivative of X plus A. A is a constant. Then this is just 1. The derivative of X is 1. So P prime at X is equal to F prime at X times X plus A plus F at X. Now we will plug A into the X. So we get P prime at A. And that is equal to F prime at A times A plus A, because X is A now, plus F at A. P prime at A is equal to, now A plus A is 2A, so we have 2A times F prime at A plus F at A. We don't know what F at A is equal to. We also don't know what F prime at A is equal to, but we cannot say it's equal to 0. And at this point, 2A, we don't know A is equal to 0. So we cannot say that this is just equal to 0. So let's look at this. Let's write down what we get for each of this answer. So let me write it down in green. So for A, we have P at A equals to, here, 2A FA. 2A times FA. P prime at A is equal to, what do we get for P prime at A? 2A times F prime at A plus F at A. So we can write it down here. Two A times F prime at A plus F at A. None of them is equal to 0 unless A is equal to 0. Or we don't know what F at A is equal to either, so we cannot say P prime at A is equal to 0. So this statement may not be true. So let's look at B. P at X is divisible by X squared plus A squared. Let's do the same thing as this here and validate it. So B. So B, let G at X equals to X squared plus A squared. Then P at X is equal to F at X times G at X. And that will be equal to F at X times X squared plus A squared, because G at X is X squared plus A squared. So we can plug A into X, so we get P at A. So F at A times G at A is equal to F at A times, X is A now, so it's A squared plus A squared. That gives me F at A times 2A squared, because A squared plus A squared is 2A squared. So I have P at A equals to 2A squared times F at A. In this question, we don't know whether A is equal to 0 or not. It did not say that A is equal to 0. So we cannot just assume that A is equal to 0. So we cannot say that P at A is equal to 0 for sure. Okay, let's look at P prime at A, because we have to meet two conditions here in the question. I will start with P prime at X, and that's equal to F prime at X times G at X plus F at X times G prime at X. So that's the derivative of P at X. So P prime at X is equal to, we don't know what F at X is, so we also don't know what F prime at X is, so we'll keep it as F prime at X. But we know what G at X is. It's X squared plus A. That's what we set that equal to. Plus F at X, because we don't know what F at X is equal to, but we know what G at X is equal to. If G at X is equal to X squared plus A squared, where A is equal to constant, then the derivative of X squared plus A squared is just 2x. So let's plug the A in. P prime at A. Plug the A into X. So now will be F prime at X, F prime at A times A squared plus A squared plus F at A times 2A. So let's simplify this further. P prime at A is equal to 2A squared times F prime at A plus 2A times F at A. We don't know what F at A is equal to. We cannot say it's equal to 0. We don't know what A is equal to, because no, the question did not say A is equal to 0. So unless A is equal to 0, then the whole thing is equal to 0. But the question did not say that, so we cannot say P at A equals to 0. We cannot say P prime at A is equal to 0 either. But anyway, we have the finding here, so let's write that down. So we know that for B, what we figure out is P at A, which is this one here, P at A is equal to 2A squared times F at A. Now what's P prime at A that we found? This one here, 2A squared times F prime at A plus 2A times F at A. So we can write that down. 2A squared times F prime at A plus 2A times F at A. That should be, yeah. Okay, so we did B. So let's do C. C is P at X is divisible by X squared minus A squared. Okay, let's try to do the exact same method like this, and we'll see how it goes. So let's erase all of this. Okay. C. Let G at X equal to X squared minus A squared. Then we will have P at X equals to F at X times G at X equals to F at X. We don't know what F at X is, but we know what G at X is, which is X squared minus A squared. That's what we set here. What is P at A then? P at A, we have F at A times G at A equals to F at A times, now X is A now, A squared minus A squared. So what's that? A squared minus A squared is 0. 0 times F at A is 0. So this is 0. Oh, nice. So we have P at A equal to 0 for try C. But don't forget, we have to meet both conditions. P prime at A has also to be equal to 0. So let's check P prime at A. So we start with P prime at X. Take the derivative of F at X. Take the derivative of P at X. So we have F prime at X times G at X plus F at X times G prime at X. So P prime at X is equal to, we don't know what F at X is, so we also don't know what F prime at X is. So we'll leave it. And G at X is X squared minus A squared plus F at X stays the same as we don't know what F at X is. Okay, now G prime at X. G at X is X squared minus A squared. Then G prime at X is 2x because A is constant. So P prime at A is equal to F prime at A times a squared minus a squared plus f at a times 2a. Now, a squared minus a squared is 0. 0 times f prime at a squared is 0. So this one here is 0. How about this? P prime at a is equal to 2a times f at a. Like I said before, the question did not say that a is equal to 0. So you cannot just assume that, oh, could be 0. We don't know that. Okay, so we have found this thing. So let's put it down here as our finding for C. So we have P at A equal to 0. That's what we found here, which is nice. It's meeting one condition. But P prime at A is equal to 2a times f at A. So this is equal to 2a times f at A. Almost there. One condition is met. Remember, we need to meet both conditions. So P at A equals to P prime at A equals to 0. The both has to be equal to 0. So let's look at D. See if they can be both 0. P at x is divisible by x squared plus 2ax plus a squared. So let's do the calculation, do the math. So we erase all this. Okay. So we will do D right now. D. Let g at x equals to x squared plus 2ax plus a squared. Okay. P at x is equal to f at x times g at x, which is equal to, we don't know what f at x is, but we know what g at x is, which is x squared plus 2ax plus a squared. Then what is P at A? We plug into x. So f at A times g at A is equal to f at A times, now this is a squared plus 2a times a plus a squared. P at A is equal to what? 2a times a, 2a squared, 2a squared plus 2a squared, 4a squared. So we have 4a squared f at A. We don't know what a is equal to. A is a constant. Only if a is equal to 0 for P at A equal to 0. So it looks like it's not really meeting the condition. But let's try. We have to also evaluate P prime at A. So let's start P prime at x. Take the derivative of P at x. We have f prime at x times g at x plus f at x times g prime at x. P prime at x is equal to, we don't know what f at x is equal to, so we also don't know what f prime at x is equal to, so we have to leave it like that. What's g at x? X squared plus 2ax plus a squared. Now plus f at x, as we don't know what it is. Okay, we know g at x, so what's g prime at x? It's the derivative of 2x x squared, so basically it will be 2x plus derivative of 2ax, so it's 2a. Derivative of a squared is 0 because a is a constant. So here we have, we can plug a into x, so P prime at A is equal to f prime at A times a squared plus 2a times a plus a squared plus f at A times 2a plus 2a. So P prime at A is equal to, this is 4a squared times f prime at A plus, this is 4a. 4a times f at A. Again, we don't know what a is equal to, and the question did not say a is equal to 0. So we cannot just assume a is equal to 0. If a is equal to 0, this will, P prime at A will be equal to 0. But it's not, so I have to leave it like this. So let's write down what we found for D. P at A is equal to here 4a squared times f at A. Now, how about P prime at A? P prime at A is this 4a squared times f prime at A plus 4a times f at A. So let's write that down. 4a squared times f prime at A plus 4a times f at A. And write the A better. Okay, now we only have one choice. It looks like all the above choices were not meeting the requirement. P prime at X and P prime at A and P at A equals 0. Okay, hopefully the last choice will work out. So let's say P at X is divisible by x squared minus 2ax plus a squared. So we will do the same thing. So let me switch back to yellow. E. Let g at x equals to x squared minus 2ax plus a squared. Okay, so we will start with P at x, and that's equal to f at x times g at x. Then we'll write this x here. So x, okay. We don't know what f at x is, so we'll leave it. But we know what g at x is. It's this x squared minus 2ax plus a squared. Now we can plug into x. We have f at a times g at a, and that's equal to f at a times a squared minus 2a times a plus a squared. P at a is equal to, now let's see what that is. F at a. Okay, now inside here is basically a squared plus a squared is just 2a squared minus 2a squared, or 2a squared minus 2a squared is 0. 0 times f at a is 0. Oh, good. We have P at a equal to 0. One condition is met. Now let's look at P prime at a, because that has to be equal to 0 in order for this to meet the requirement in the question. So let's begin. P prime at x, take the derivative of P at x, which I will have f prime at x times g at x plus f at x times g prime at x. So P prime at x is equal to, we don't know what f at x is equal to, so we also don't know what f prime at x is equal to. So leave it like this. G at x will be, here we have this here, x squared minus 2ax plus a squared plus f at x, as we don't know what it is, times g prime at x. We know g at x is equal to x squared minus 2ax plus a squared, so derivative of x squared is 2x. Derivative of 2ax is 2a. Derivative of a squared is 0 because it's a constant. Now we can plug a into x. So P prime at a is equal to f prime at a times a squared minus 2a times a plus a squared plus f at a times 2a minus 2a. P prime at a is equal to, okay, let's see what it is. This is f prime at a times, basically this is 2a squared minus 2a squared plus, okay, 2a minus 2a is 0, and 0 times f at a is 0. So P prime at a is equal to 2a squared minus 2a squared is 0. 0 times f prime at a is equal to 0. So 0 plus 0, P at prime at a is equal to 0. Oh, what do we see? So we have P at a is equal to 0, And then P prime at A is also equal to 0. Is that what we're looking for? So let's write down our finding. For E, P at A is equal to 0. P prime at A is equal to 0. Now, again, what are we looking for in the question? P at A is equal to P prime at A equals to 0. So with all these choices here, choice A, unless A is equal to 0, or even F at A has to be equal to 0. Otherwise, it would not be equal to 0. So choice B, still, A has to be equal to 0 in order for this to be equal to 0. But the question did not say A equal to 0. So A could be equal to anything. So choice C, P at A is 0, but P prime at A is not. Choice D, none of them is equal to 0, unless A is equal to 0. But choice E, P at A equals 0, P prime at A is equal to 0, regardless what value of A is. So that means the answer to this question is E. So statement E must be true. Hope you enjoyed this video, and don't forget to subscribe to my channel. Thank you.